On today's video, we'll be determining the formula unit for ionic compounds using the crisscross method. Before we begin, I just want to take a quick look at the valence charges on ionic compounds, and in order to do that, we need to be able to recognize what are the valence charges on our individual atoms and our individual ions. Everything in group 1, as we recall, becomes a +1 ion. Everything in group 2, a 2+. Then we have a 3+ charge over here. We have no charge right now. We're not going to deal with this, so just cross this off. This does not apply to us right now. We have a 3- charge, a 2- charge, and a 1- charge. And as we recall, all these elements over here will lose their outer shell electrons, and all these elements over here will gain their outer shell electrons. And as a review, let's define an ionic bond. An ionic bond is an attraction between a cation and an anion. And so if I examine this picture over here, I can see an ionic bond over there. I have an ionic bond going in this direction, an ionic bond in here. These are all attractions between cations and anions. And likewise, this negative ion is attracted ionically over here, this positive to this negative, and this framework of bonding does continue over and over again. So these are all examples of ionic bonds. So it's an attraction between a cation and an anion, and it results from the transfer of electrons. So it's resulting from the transfer of electrons. We're also going to find ionic bonds are typically between metals and nonmetals, the left side of the periodic table and the right side of the periodic table. Metals tend to lose their electrons, and the nonmetals will be the elements that gain their electrons. So nonmetals will become negative, and my metals will become positive. So when you lose electrons, you become positive. When you gain electrons, you become. An ionic bond can also be considered a framework of positive and negative charges. So as I examine our picture here, my negative right here has an ionic bond to the next particle, which is a positive, and that is my attraction, the negative-positive attraction. And likewise, that's going to go over around this way, the negative is attracted to the positive on that side, and the same way over here. And these are all examples of ionic bonds, and you'll see them throughout this whole entire picture here. And I'm not going to circle every one, but that is what an ionic bond is, an attraction between a positive and negative ion, resulting from the transfer of electrons. So let's go to our objective for today. What is the formula unit for magnesium fluoride? Okay, we're going to learn a new method today. In the past, we've learned determining the formula unit, making a Lewis dot structure. Today, we're going to introduce you to a new concept, and that is called the crisscross, or crossing the charges. I want you to draw the elements, magnesium and fluorine. I want you to take the charges. Magnesium is a 2+ charge, fluorine is a 1-. This comes directly from the slide a few slides ago where I showed you the charges. And if you want to determine the formula of magnesium fluoride, all you need to do is cross the numbers. The 1 comes here, the 2 goes over there. And what this translates then into is an Mg with a 1 and an F with a 2. And this is the formula unit for magnesium fluoride. It's as simple as crossing the charges. I will also add the 1 does not need to be written. Okay? Whenever I have a 1, I can just omit it and just leave MgF2. To be a little more clear, I have made this slide as well. And I'm showing you the charges, 2+ and 1-, and I want you to cross the charges. Once again, here is my 2, and it is going over there, and here's my 1-, and I'm not taking the minus, but I'm just taking the 1 and bringing it over there, and the final answer is going to be MgF2. I also want you to know that this is nothing more than 1 2+ ion, which is magnesium. It has a 2+ ion, and also 2 1- ions, because I want you to understand that I have to add all these up, -1 plus a +2 plus a -1, and their overall charge is going to be 0. Okay? Ionic bonds will always have a final charge of 0. That's right, I have 1 2+ ion and 2 1- ions. In this case, when I add them all up, the overall charge is 0. You could also get the same answer of MgF2 making a Lewis dot structure as well. Next question, what is the formula unit for sodium phosphide? Na has a 1+ charge, phosphorus has a 3- charge, and I'm going to take the 3 and cross it over here. Take the 1 and cross it over here. And what you see over here is that I have Na3P1 And when I clean the problem up and remove the charges from the top, I'm going to see my formula unit is Na3P. If I look at it from this view, there are 3 1+ ions. I have 3 1+ sodium ions and 1 3+ phosphorus ion. Altogether, my 3 pluses are going to cancel out with my 3 negatives, give me an overall charge of 0. Alright guys, what I would recommend for you to do in the next following slides is to attempt these first and then try to see if you get them right. Press pause. Attempt aluminum oxide, give me the formula or the formula unit for it by crossing charges. Okay, we're back here guys. Aluminum has a 3+ charge, oxygen has a 2- charge. When you crisscross them, you end up with Al2O3, and here we are. Okay, so try once again on the next slide, press pause, take a shot at yourself. Just a little reference here, 3 times 2 gives me a 6+, and I just want you to see that -2 times 3 gives me a -6. And the ionic bonds, the ions will always cancel each other out in their total charge. Barium oxide is a good question. All right, barium oxide is a unique question. Please make an attempt at it. Let's see if you get the right answer. Okay, this is what I got here. I have a 2+ charge that's going to be crossed over to oxygen, a 2- charge that's crossed over to barium, and what you end up with here is a 2-2 ratio. But we're not done yet. You have to simplify it and reduce. Reduce down to the lowest common number here. In this case, 2 and 2 can reduce down to 1 and 1. And the final formula unit for barium oxide is Ba1O1 or BaO. Same way here, guys. Press pause. Try to attempt writing the formula unit for calcium nitride. So calcium is a 2+ ion. Nitrogen is a 3- ion. I cross them to have 3 and 2. And that's what we're seeing over here. We're seeing the 3 and the 2. Now these cannot be reduced any further. And so my formula unit is Ca3 and 2. Please try drawing the formula unit for sodium fluoride. Sodium is a 1+ ion. Fluorine is a 1- ion, and I cross them. And what you're going to see here is that we have 1s and 1s on the bottom. And whenever I have 1s, I do not need to draw them in the actual final representation of my formula unit. In this case, the formula unit is Na1F1 or NaF. Alright guys, please try the formula unit for aluminum phosphide. Okay, give me the formula unit for aluminum phosphide. Press pause, take a shot at it, please. Okay, I hope this is what you got. Aluminum has a 3+ charge, phosphorus has a 3-. You crisscross them, and I end up with 3 and 3 at the bottom. And you know the drill by now. Whenever I have common numbers at the bottom, I can reduce them. And I'm going to reduce it down to Al1, P1, and that's ALP. So the whole goal of this lesson was to determine the formula unit. Okay, give me the formula unit, also known as the formula, using the crisscross method. And that is simply crossing the charges. And I will give a little example here of what we had done in the past. We had used a Lewis dot structure in order to determine the formula unit. And that is kind of what I'm doing over here. And I showed a transfer of electrons over there, a transfer of electrons over there, and a transfer of electrons over there. And altogether I have counted 1 aluminum and 1 phosphorus. And my formula unit in the past, we've just done this, ALP. And that was using our Lewis dot structure. Today, once again, just trying to get to the formula unit using a different method, and that method was crossing charges, but both answers are going to give me the same, both questions rather, both solutions are going to give me the same answer, and that is a formula unit in the lowest whole number ratio possible. Okay guys, hope this helped. Best wishes. Catch you later.